We have this exercise in analysis. We have a function of two space coordinates, x1 and x2, which is given by this relationship f equals x1 squared plus x2 squared. And f is C1 function in omega, where omega is a subset of the two-dimensional Euclidean space. And what needs to be proved here is the first result, that the difference between the derivatives of the function with respect to the two coordinates is equal to a constant m times the absolute value of the difference x1 minus x2. And question number B, we have the first derivative with respect to the first coordinate space variable x1 raised to the power of 2 minus the partial derivative with respect to the space coordinate x2 raised to the power of 2, and this is bounded by a constant times x1 in absolute value plus x2 in absolute value raised to the power of 2. Let's prove number 1. Let's prove A. We have the partial derivative with respect to x1 minus the partial derivative with respect to x2. The partial derivative with respect to x1 is 2x1 minus the partial derivative with respect to x2 is going to be 2x2. So I can take common factor 2 and I have x1 minus x2, and that's going to be absolute value of 2 times absolute value of x1 minus x2, and that is 2 times the absolute value x1 minus x2. So we have that the partial derivative with respect to x1 minus the partial derivative with respect to x2 equals m, capital M, times x1 minus x2, and in this case m is equal to 2. So let's go to the other one. We have partial derivative with respect to x1 raised to the power of 2 minus partial derivative with respect to x2 raised to the power of 2. It's going to be 2x1 squared minus 2x2 raised to the power of 2. That's going to be 4x1 squared minus 4x2 squared. I take common factor 4 and I have x1 squared minus x2 squared. That is the difference between the two squares, x1 minus x2 times x1 plus x2, and that's going to be 4 times absolute value x1 minus x2 times absolute value x1 plus x2. And then this can be bounded by 4 times, I bound this by the triangle inequality x1 plus x2 times, I bound this by triangle inequality absolute value of x1 plus absolute value of x2. So that's going to be 4 times x1 in absolute value plus x2 in absolute value raised to the power of 2. So that one is going to be bounded by 4 times absolute value of x1 plus absolute value of x2 raised to the power of 2, and this can be written in the following way. Capital L times x1 absolute value of x1 plus absolute value of x2 raised to the power of 2, where L is equal to 4. And this proof is now complete for both arguments A and B.